Informed by nearly 3 decades of experience supporting the unique and changing needs of modern bridge engineers, LARSA's 4D Bridge Series software includes many specialized features which allow our clients to work effectively and efficiently. To simplify the modeling of curved bridge paths, LARSA 4D's Bridge Path Coordinate System allows our users to work in simple coordinates despite any curvature of the structure by warping the usual x-axis into a curve that follows the center line of the bridge. Instead of traditional XYZ coordinates, this system uses the station, elevation, and transverse offset of the bridge to define geometry. For more complex projects, multiple bridge paths can be used within the same project to define spiral on and off ramps, girders, ground level footings, and more. For steel girder bridges, LARSA's Steel Bridge module provides an intuitive, parametric modeling environment to support everything from simple line girder bridges to complex projects featuring heavy curvature and skew with concentric girders, irregular spacing, and variable deck width. Streamlined into 4 task-based steps, the module begins with Task A, which defines the basic parameters of the bridge such as span length, number of girders, substringers, crossframe and splice point locations, deck material, and the geometry of the deck, which uses LARSA's Bridge Path Coordinate System. To accurately capture the behavior of the bridge, flexible finite element modeling options are available for eye, box, and tub girder bridges, which allow girders to be modeled as line elements representing the web and flanges together, or as a composition of plate and shell elements for the web and line elements for the flange. The second task integrates the necessary information to generate load cases, the full construction modeling of the bridge including stages for the deck pouring sequence and screed movement, results combinations, and live loads according to AASHTO LRFD. Unique to LARSA 4D, the Steel Bridge module extracts results from the analyzed bridge model and automatically processes them in accordance to AASHTO LRFD code requirements in Task C. Based on LARSA's staged analysis engine, the code check takes into account the effects for curvature, skew, transverse bracing, and time effects for material properties to provide reports for strength, service, constructability, and fatigue, along with options to check for stiffeners, cross frames, substringers, and live load deflection. Once completed, the module introduces 4 code check reports, which vary from a simple pass-fail report to a verbose report which displays the full computation of equations and values used as step-by-step formulations for each code check location. With the ability to step beyond a typical 2D grillage analysis, the influence surface-based analysis results are used to perform LRFR load rating in Task D, in which rating factor results are displayed for live load combinations, which support any permit or custom-defined vehicle. While there are many unique analysis types available in LARSA 4D, such as vehicle track structure interaction for high-speed railroad bridges, perhaps the 2 most critical are influence surface-based live load and staged construction analysis. To save the user the time of choosing lane locations, modeling separate influence lines, and performing factored combinations, LARSA 4D's influence surface-based live load uses powerful algorithms to automatically compute the worst-case loading configuration for plate deck models and automatically locates the transverse locations of as many lanes as will fit on the surface. As pioneers of time-based 4D analysis techniques, the staged construction analysis capabilities of LARSA 4D are without equal. Used to model the changing state of a structure over time with structural changes, load applications, and time-dependent material effects, LARSA's staged construction analysis with geometric and material nonlinearity is critical for structures with large displacements. With full construction activities included for the construction and deconstruction of members, plates, springs, and foundations in addition to loading, support, constraint edges, displacement initialization, and hoist for incremental launching, LARSA accurately models the construction sequence for the project in discrete stages and steps, so that the cumulative effect of each load class can be reported separately for code-based load combinations. Each construction activity is associated with a load class, such as self-weight, dead load, live load, or pre-stress. Extensively used on cable-supported bridges, LARSA uses optimization algorithms which help find the cable forces to give the structure its intended final geometry. When working with post-tensioned cables, LARSA's post-tension load iteration process will force the rest of the structure to adjust in order to keep the cable force constant within the specified magnitude, simulating the jacking operation at a constant force of a cable. As a cohesive finite element software for bridges, each LARSA 4D license also comes preloaded with our Section Composer tool, which supports non-prismatic variation for acute modeling of bridges whose dimension vary along the length of the member. Using this tool, formulas are used to provide the value of a parameter as a function of position along the length of a span, such as linear, parabolic, or depth. With unmatched capabilities and the flexibility to integrate the modeling, analysis, and design for even the most demanding of projects, LARSA 4D has grown to become the most trusted software solution at leading bridge design firms in the U.S.